Hi, this is Leah from Open Intro. In this video, we will see how to use normal approximation for the distribution of a sum. Suppose the weights of the checked baggage of airline passengers follow a nearly normal distribution with mean 45 pounds and standard deviation 3.2 pounds. What is the probability that the total weight of 10 bags is greater than 460 pounds? Here we're interested in a sum or a total. We want the probability that the total is greater than 460. However, we don't necessarily know the standard deviation of a sum. In that case, we could change the problem from being about a sum to being about an average, because we do know the standard deviation of an average. So, in order for the total to be greater than 460, the average has to be greater than the 460 divided by the sample size of 10. So we need the sample average to be greater than 46. If this is true, then the total weight will be greater than 460. And so now we've turned the problem into just an average problem that you already know how to do. And so we're going to need the mean and the standard deviation for the average. We know the mean is just the mean of the original population. That's given as 45. When we're dealing with a sample average, we divide the original standard deviation by square root of n. So here we're going to have the 3.2, the standard deviation of the population, divided by the square root of our sample size, 10. That gives us 1.01. Now, before we do normal approximation, we should make sure that it's applicable in this scenario. It's given that the weights follow a nearly normal distribution. So since that's given, we know we're allowed to use normal approximation, even though our sample size is small. So we can find our z-score, which is the value of interest, 46, minus the average, divided by the SD. And now we want greater than, so we want to find the area to the right of this z-score under the normal curve. So you can use whatever technology you like. If you're using a TI, then you can go to second vars, which is distribution, and choose number 2, norm CDF. We want to be to the right of 0.99, so 0.99 is our lower bound. Our upper bound is some very large number such as 6, since it's unspecified. And then hit enter, and this will give us 0.161. That's it for this video. For more free resources, check us out at openintro.org.